This is chapter 3.3, Properties of Logarithms. The properties of logarithms that we're going to learn today are these three: the product property, the quotient property, and the power property. So the product property states that log base A uv equals log base A u plus log base A v. The quotient property, log base A u divided by v, equals log base A u minus log base A v. And the power property, log base A u to the n power equals n log base A u. Now these properties are important. We'll be using them a lot, so make sure you write them down and study them. And now let's look at a few proofs of these properties, because as usual I like to prove properties to show students where they come from. So a little proof of the product property. Let's say that we set x equal to log base AU and y equal to log base AV. You can always do that. You can always define a variable. And we're just defining a variable, x as log base AU and y as log base AV. Now, if these definitions are valid, then a to the x equals u and a to the y equals v. And that's simply from the very essence of logarithms, because logarithms are exponents. And we can simply rewrite x equals log base AU as a to the x equals u, because that's the essence of logarithms. That's the definition of logarithms. Logarithms are exponents. And so also a to the y equals v for the very same reason. Now, if we multiply u by v, we have uv equals a to the x times a to the y. And that's just simple replacement of u and v with what we've already defined. And that in turn equals a to the x plus y. And that's just algebra 2 stuff that you already learned about how multiplying exponents works. And so a to the x times a to the y equals a to the x plus y. Now if we do a log base A of both sides, and that's simply a fundamental property of algebra, fundamental theorem of algebra, sorry, and that simply is that whatever you do on one side of the equation, you do on the other. So we have log base A uv equals log base A to the x plus y, and that equals x plus y. And we know that from the identities that we already learned, because a to the what is a to the x plus y? Well, x plus y. And that's simply a rewriting of log base a to the x plus y is x plus y. Now, log base AUV equals log base AU plus log base AV. All we did there was replace x with log base AU as we defined in the first line of the proof, and we replaced y with log base AV as we did in the first line of the proof. And that is our product property fully proven. Log base AUV equals log base AU plus log base AV. A proof of the quotient property. Let x equals log base AU and y equals log base AV. Same first step. And of course the same second step. It's just a consequence. A to x equals u, a to the y equals v. U divided by v equals a to the x over a to the y. And that in turn equals a to the x minus y. It's basic algebra 2 behavior of exponents. Log base A u over v equals log base A to the x minus y. And that simplifies down to simply x minus y. Therefore, log base A u over v equals log base A u minus log base A v. And we've proven the quotient property. Proof of the power property, same first steps. And we have a to the x equals u, a to the y equals v. Now let's write log base A u to the n equals log base A to the x to the n. And all we did there is we replaced u with a to the x as already defined in the second line of the proof, because we're trying to prove the power property, which starts with log base A u to the n. Now log base a u to the n equals log base a to the xn. And that's simply algebra 2 behavior of exponents. And so the parentheses disappear. And that means that log base a u to the n equals xn, because log base a to the xn, reduces to simply xn by the logarithmic identities we already learned. And finally, log base a u to the n equals log base a u times n. And finally, we have the last step of our proof, log base a u to the n equals n log base a u. Now these three properties you just learned, the proofs are important to see where they come from, but now it's up to you to memorize them. So you have to write them down, you'll have to study them, but the three properties we just learned need to be etched into your brain because you're going to use them a lot, and you can't be looking them up all the time, so you need to memorize them. And a lot of math and science is like that. The proofs are readily available. Some are more complicated, some are simple. But whether the proofs are complicated or simple, it's simply inefficient to prove everything every time. And so there is a certain amount of memorizing involved because it's simply more convenient to memorize the formulas. It's great and important to know the math behind them and to know how to prove them. But it really does come down to memorizing key properties and identities and formulas. This is true of all math and science, and so it's a good habit to get into. The last formula we'll learn today is the change of base formula. Log base ax equals log x divided by log a equals ln x divided by ln a. And so this formula is useful for most calculators which don't allow you to change the base of your logarithm. They just have the common log, log, or they have the natural log, ln. And so this will allow you to evaluate any logarithm regardless of its base. As an example, evaluate log base 5, 37 on your calculator. So just plug it in the formula and see what you get. This is just to practice doing it on your calculator. Pause the video, do that, and resume when you have your answer. So you should have gotten 2.24359. And you'll get the same number whether you use the common log, log x over log a, or the natural log, ln x over ln a. Let's do a proof of the change of base formula. So our first step is just like the proof of the other properties that we've done. X equals log base AU. We're just defining x as such, and therefore rewriting it. A to the x equals u by the very definition of logarithms. Now the next step is to do log b of each side. So log base b, a to the x equals log base b u. Then we have, by the power property, x log base b a equals log base b u. And finally, we have log base a u times log base b a equals log base b u. All we did is replace x with the log base a u that it was defined as. And then the very last step is log base a u equals log base b u divided by log base b a. And that's the change of base formula. Now let's look at some examples. Log base 5 root 13. And I've done the first step for you just as a reminder because people sometimes forget that square root is the same as the 1/2 power. And so this is a convenient way to rewrite a logarithmic expression that has a radical. And that, of course, equals 1/2 log base 5 13, which in turn equals 0.79685. And you can get that by using the change of base formula on your calculator. Next example, ln x to the 6 minus ln x squared. Pause the video, do that on your own, and resume when you have your answer. Okay, so going through the steps, we have first rewriting it using the quotient property. Ln x squared over, I'm sorry, x to the 6th over x squared, that quantity in parentheses. And then we just evaluate that expression in the parentheses, and we have x to the 4th. And then we use the power property to come up with 4 ln x. And that's the most we can simplify this expression. How about this? Expand log base 4 5x cubed y. Now all expand means is, well, it's just like it sounds. You are going to write it out in a longer form with many terms instead of only one term. So what you try to do is write this out in as many terms as you can. So use the properties to do that. Pause the video, do this, and resume when you have your answer. So you should have come up with log base 4 5 plus log base 4 x cubed plus log base 4 y. And that's just using the product property that we already know. And then the next step, log base 4 5 plus 3 log base 4x plus log base 4 y would be the full expansion. And finally, condense 1/3 log base 2x plus log base 2 x plus 1. Pause the video, do this on your own using the properties, and resume when you have your answer, which should just be one term. Okay, so you should have come up with this log base 2 x times x plus 1 to the 1/3 power. So we've now crunched everything down into one term using the properties. So that's what you need to do if you see expand or condense in any problems you're given. The classwork, page 243. Write these numbers down, and see you in class.